Deextinction, also known as resurrection biology, is the scientific theory and practice of generating organisms from different methods in order to bring a species back from extinction. Revival of a species from extinction can lead to severe ecological effects and changes within an ecosystem, and impacts are uncertain, as they may improve or hinder current conservation strategies and efforts. The main goal of de-extinction is to restore species to their former habitats and ecosystems, and to possibly undo historic extinctions, whether these were caused by human influence or not. There is an immense interest in the reversal of human impacts on wildlife and species. However, there are complications and unknown consequences to the revival of extinct species. These three species were contenders or considered for de-extinction. The woolly mammoth was a serious contender, but it's still proving to be a little bit difficult. The Pyrenean ibex underwent cloning and was released into the wild as a clone. Unfortunately, it was one of the only species to go extinct twice. The black-footed ferret is currently an endangered species within the United States, and it underwent cloning and was the first U.S. endangered species to undergo cloning. The practice of de-extinction involves editing of the genome as well as the use of selective breeding. This practice is most commonly used in already extinct species or soon to be extinct due to critical endangerment. And for still existing species, these processes can be used to help boost genetic diversity within a vulnerable species population or improve population numbers. There are several processes that can be used, including cloning, genomic editing, and selective breeding. Cloning replicates the genome of an individual organism and creates an exact genetic copy of an organism. Genomic editing is a group of processes that allows for the genome to be edited through addition, removal, substitution, and alteration of specific loci of genetic material. We see this mostly used in recently extinct organisms, when the cells are most readily preserved. And selective breeding can be used to use desired characteristics in parents to help influence those characteristics in the offspring. It's the process involving selection of these characteristics, and it's often used for endangered species rather than extinct. An example of one of these processes of cloning is Dolly the sheep, who was born in 1996. She was the first mammal to be cloned from an adult cell, and she was one of 277 attempts that was successful. Ultimately, she lived a completely normal life until she passed away from health conditions. And her cloning process was rather simple. A donor cell was taken from a sheep's udder, where the nucleus was removed and placed into the egg cell of the female donor. And these two cells are fused using electric shock, where the cell begins to develop normally, separating and splitting into creating an embryo. And this developing embryo is placed inside the uterus of the mother, where it develops into a fetus and an exact genomic copy of the donor nucleus. Another example of this is Elizabeth Ann, who was a cloned black-footed ferret. She was born in 2020, and she was the first ever United States endangered species to be cloned. Her species is endangered and has already extremely limited genetic diversity, but her birth signified a change in the world of conservation biology. However, cloning isn't the be-all, end-all to bringing a species back from extinction. Even with all the complications involved with reviving an entire population of species from extinction, there are still some ethical dilemmas at play. Researchers and scientists are constantly considering the possible effects of reintroducing an extinct species to their historic habitat and ecosystem. And so, two questions normally arise from the conversation of de-extinction. 1. How can we do it? What are the processes that we can use to bring species back from extinction and revive them into their former glory? And 2, should we? Is there an ethical dilemma at play with bringing species back? Are there moral and philosophical quandaries that we have? Let's look at some advantages. In the biological context, there are advantages to de-extinction. For one, the advancement in genomic technology and processes paves the way for cloning and species replication. As we're currently undergoing one of the largest biological extinctions in the 4.6 billion years of Earth's history, these processes can help to prevent the extinction of many of our endangered species and help to minimize the impacts of these extinctions. These could be used in a conservation context to help clone extinct and endangered species in order to return them to the wild, or, in fact, sustain wild populations and maintain genetic diversity. The current processes could be used in direct conservation strategies, or it could be used as a redemption method to bring species back that have become extinct or endangered from human impact. Though these advantages seem nice, there are significant disadvantages, biological disadvantages to de-extinction. For one, there are uncertain impacts of revived species on current ecosystems and native species. Reintroduction of revived species may negatively impact an ecosystem species via competitive exclusion, in which an introduced species is more well adapted than a native species to an area. We see this commonly in introduced and invasive species, and we can't really be certain of the effects from extinct species on ecosystems that they primarily inhabited. This introduced pressure of de-extinct species on currently endangered species could even drive faster extinction rates due to resource competition, and species that we did choose to undergo de-extinction may not have the same ecological roles as they once did, which may put unnecessary strain onto current endangered species. They could reverse conservation efforts that we have succeeded in over the past decades by driving these endangered species closer to extinction, and they may create funding limitations for effective conservation strategies if more money is being spent in favor of cloning and these de-extinction processes as opposed to conservation. One example for the Mammoth Steppe, which was once a large glacial area filled with fertile grasslands, was home to megafauna and has disappeared due to global warming and climate change over the past thousands of years. Would it be inhumane to bring mammoths back into existence only for their natural biomes to not exist anymore, and for them to be introduced into biomes that are inhabited by present-day species? Beyond the biological context, there are an incredible amount of ethical issues regarding de-extinction. For one, would de-extinction force revived animals to be placed in captivity for long periods of time before release and reintroduction into the wild, as these populations are going to need to be built? Also, what constitutes a species, and what species are deserving of revival? If we look at the revival of the woolly mammoth, genomics can use available mammoth DNA and have to use edited DNA from elephants in order to achieve the physiological factors desired for this new mammoth. If a revived species looks like and has a similar genome but different behavioral strategies in its ancestors, is it the same species? Is it really the same species of mammoth? The genome has been edited and it's half of an elephant? What would introduction look like for this new species, and what would it entail for other organisms of that ecosystem? What about the question of whether or not it's humane to bring a species back whose ecosystem is gone? What about health impacts or heightened health issues, such as in Dolly the sheep's case, in which only 1 out of 277 attempts at this succeeded? What about, does this continue the issue of exploitation? Are we only picking animals that we enjoy to look at, that we would like to have back, as opposed to a significantly helpful plant? Is there favoritism? A lot of these ethical questions are really important in the conversation of de-extinction, as there is no right answer. So we have to ask ourselves, 1, how can we do this? And 2, should we?